Hello, and thank you for joining me for today's lesson on significant figures along with accuracy and precision. So to start with, accuracy and precision are two words that we use rather interchangeably, but they are different in the scientific world. So for starters, accuracy is used to describe how close a measurement is to the true value of the quantity measured. So we're looking for how close it is to the actual or true value. So if the answer is 3.2 and I get 3.17, that is fairly accurate. That's accuracy. Precision is exactness, or how close a set of measurements are together. So in this case, the answer is 3. If I get 4.2, 4.15, 4.22, 4.18, all of those are very close together, so my reading was precise but not accurate. And this is kind of a visual demonstration of it. So this first picture, you see that you have a target and you have dots, or you've hit the target in numerous different places, none of them being the bullseye and none of them being real close together. So that's very low accuracy, very low precision. This guy, you've hit very close to the center. So we have 1, 2, 3, and 4 marks all right around that center point, but they're not real close together themselves. So this would be an accurate, and a case of accuracy because they're all near the correct value or the center, but they're not very close together, so it's not very precise. So low precision. Our next one, you have a clump of 4 dots here that are all very close, very tightly packed together, not where they're supposed to be on the target, but very consistent there. So this is low accuracy because they're not on the target, but it's very precise that they're all hitting relatively the same spot each time. And the last one is ideal, that we have accurate and precise. We're hitting the correct value. We're hitting it numerous times. That is the goal in measurement, but that's high accuracy and high precision there. So there is a difference between those two terms, and you will need to be able to differentiate between those two words. One of the ways we show precision, specifically, is that we use what are called significant figures. And so significant figures are all of the known values, so all known values with one estimated digit. All known values with one estimated, not just stimated, digit. And that's for reading. That's for getting a reading with sig figs. When we use them in calculations, we have 4 rules for how we use significant figures to make sure that our answers still reflect those numbers that we know and estimate. So these rules are zeros between non-zero digits are significant. For example, 5.03 has 3 significant digits because there's a non-zero with 5, a non-zero with 3, and the zeros in the middle. So this is kind of implying or going without saying anything that's not 0 is considered significant because we had to measure it. Zeros at the end of a number behind a decimal are significant. So if we have a decimal and there's numbers to the left that aren't 0, the zeros behind the decimal are significant. So this one has 4 significant digits. This one, because there's a number that's not 0 here and a whole bunch of zeros after the decimal, there are 7 significant digits there. Rule 3, zeros at the end of a number and in front of a decimal are not significant. So if there is no decimal, and I have numbers here, so 1 and 1 are both significant. There's 2 zeros, but I don't have a decimal place, so those are insignificant. There's only 2 significant digits there. 20, again, 2 and 0, there's no decimal, so I only have 1 significant figure. And the last one, zeros in front of a non-zero digit are not significant here. And this is, again, I have a decimal that's not 0, or that is 0. So this is not significant. These are my 3 sig figs. On this one, because all these are zeros, this is my only significant figure. Personally, I think those rules are rather difficult to learn and know and remember. So let's go with a shortcut, shall we? I want you in your notes to draw a map of the United States. And voila, there you have it. In the middle of this, to make sure we know it's the United States, I want you to write USA. Okay, so if you know that that's the United States of America, we have two large bodies of water, one on either side of us. So on the west coast, there's a large body of water over here called the Pacific Ocean. So if you label this the Pacific Ocean, we can work with that. On the east coast, you have another large body of water called the Atlantic Ocean. Okay? The reason I use the Pacific and Atlantic Oceans is because of the letters they start with. So if I change the United States of America, instead of an A, if I put a D here, make it the United States of decimals. So I have the United States, of decimals. United States of decimals, okay? So now, if you can think of that, the only thing you need to look for in a number is if there's a decimal present or not. So I'm going to give you a list of numbers. So 5.00, 500, 0.0500, and which one haven't I used yet? We'll start there. For starters, okay, so we're going to look at which direction we're coming into the United States of decimals, or we could call it the United States of numbers, maybe that'd be a better word, but I've always done decimals. Okay, so I'm looking for a decimal. Decimals can either be there or they cannot be there. And another word for being there is present. So present starts with P, and Pacific starts with P. So if a decimal is present, you're going to come into your number from the Pacific Ocean or the left side of the number. Okay? So for example, I have 5.00. I'm going to come into this number from the left side because this is my decimal. So I'm coming in from the Pacific Ocean side. I'm looking for my first non-zero. In this case, my first number is a 5. 5 and 0 are not the same, so that is a non-zero. I'm going to count 5 as significant, and I'm going to count everything after it also as being significant. So this number will have 1, 2, 3 sig figs. 3 significant figures. Okay? The other side of the country has the Atlantic Ocean on it. Atlantic starts with A. And if present means there, a word that means not there, that starts with A, is absent. So in the case of a number that doesn't have a zero, or doesn't have a decimal, the decimal is absent, I'm going to start from the Atlantic Ocean side and go this way. So in this case, I have the number 500 without a decimal. Because there's not a decimal, I'm coming in from the Atlantic Ocean, from this side. I'm going to go and find my first non-zero. In this case, the first number I come to is a 0. Second number I come to is a 0. The next one is a 5. So the only one, so my 5 is my first non-zero, and I count this and everything after it this way, and there's nothing over there. So this only has one significant figure. And that follows right along with our rules. Okay? The last one is 0.0500. So first thing you look for is a decimal. Does it have one? In this case, yes, your decimal is going to be right here. Okay, so because it's got a decimal, we come in from the Pacific Ocean side, from the west coast, and we're going to come into our number this way. We're looking for a non-zero. So coming in, my first number is a 0, go through it. Another 0, go through it, and then I get to a 5. This 5 is not a 0, so we're going to count it, and we're going to count everything after it. So I have 5 and I have 2 zeros behind it. So this number is going to have 3 significant figures. That is my shortcut for how to identify how many significant digits are in a number. So you can try it out some more if you want to, looking at numbers, but that is how you do it. Okay, the last little bit we need to talk about is sometimes I will give you just a number, but a lot of times you must do calculations. So when you do math with significant figures, So math with sig figs. You have to round your answer to the correct number of digits. So if you, in my class, you say, how many numbers do I round to? I'm going to tell you to round to the correct number of significant figures. Most of the things we do in science are multiplying and dividing. So right now, this is the only one I'm going to worry about. We're not going to touch addition and subtraction. At this point in time, we're going to ignore that. But when multiplying and dividing numbers, we round our answer to match the least number of significant digits in the numbers being manipulated in the equation. For example, I have 8.871 meters times 9.41 meters. So I'm going to multiply these two numbers. When I do that, I get this situation and I come out to 81.08094 meters squared. Okay? I don't want to see this answer on your test. What I want you to do is round that to the correct number of significant digits. So your first thing you need to do is how many significant digits did you start with? So this number 8.871 had 4 because all of those are not 0. And this one 9.41 has 3 because all of those are not 0 either. So I have 3 on this one and 4 on this one. Is 3 or 4 bigger? In this case 4 is bigger, so we want the smallest number. I should ask which one is smaller. I want the smallest number, so we're going to round our number to 3 significant digits. So when I look at my answer, I had around this 81,300 or 08094 to 3 numbers. So I'm going to look. The 8 is my first number, 1 is my second number, my third number is a 0. I'm going to look. I'm going to rewrite this. 81.08094 meters squared. So this is my first number, my second number, this is my third number, my third significant digit. Now I'm going to look 1 to the left, or 1 to the right, sorry. My 8, is it going to round my 0 up or down? And because 8 is bigger than 5, it rounds it up, which makes this 0 a 1. So my final answer is going to be 88.1 meters squared, or square meters. And that is how we do significant figures. I've given you a practice worksheet, so you can do some more practice with it if you'd like. If not, please go ahead and prepare for your check for understanding, and we'll go from there. Until next time, you guys enjoy the rest of your day.